Okay, so our next speaker, and I'm probably going to butcher his name, but Javed Iqbal. He'll come up and you can say how his name is really pronounced. But he's an assistant professor in the Department of Agronomy and Horticulture at the University of Nebraska. And his focus is research on nutrient management and water quality. Thanks so much for being here today.
Thank you.
All set up?
I think I'm set up. Hey, can you hear me well? All right. Okay. Thank you, Bruce, and thanks for inviting me here. Really appreciate this opportunity today to share the phosphorus work from Nebraska. Okay. So in this presentation, today I'm going to share with you some of the work that we have been doing to optimize phosphorus recommendations using different phosphorus fertilization strategies in Nebraska. So first I want to recognize faculty, staff, and students. Those have been involved in doing some of the P work in Nebraska. When I joined UNL in 2019, there were some faculty there. Charles Wortman, he was there. Richard Ferguson is still there. Charles Shapiro retired before me. And then Dan Walter and Gary Hergard are some of the other folks that have worked heavily on the phosphorus work. So really appreciate their work. So here is just an outline that what I'm going to share today. I will be sharing some of the past research work and then what we are doing currently on the phosphorus recommendations. So first I would review the nutrient recommendation strategies and then share some of the past work on the phosphorus recommendations. And then we now know that there are some questions, there are some concerns about the phosphorus recommendations. Do we need to revise our recommendations? There are a lot of questions from the stakeholders. So regarding the high yield, so how the recommendations are going to change if the yield is going high. And then what is the long-term sustainability for using the current level that we have. And then we have done few studies on the phosphorus in Nebraska, and I will be sharing the results from one long-term study today. So where we try to look at the crop yield response to phosphorus, and we were also looking to see how the weather patterns affect phosphorus recommendations. Not the weather that we are seeing today, it's other weather. So it's not minus 20 degrees that we are seeing. And then we will be looking at the most effective phosphorus fertilization strategy. And then again, figure out if we need to change our P recommendations, and at the end, I will wrap up. Okay, so Jason did a good job of explaining the correlation calibration that I'm not doing it here. So that's good that he has already explained those concepts. But what I'm sharing here is the phosphorus fertilization application strategies that we use to recommend our phosphorus, for different farms. So there are typically three kind of phosphorus fertilization strategies. One is the deficiency correction approach. The second one is crop removal, and then maintenance and build approach. So the deficiency correction approach is again a kind of approach that optimizes profit. It is based on the critical level that Jason shared earlier. And then above that critical level there is no response. But again, there are with this deficiency correction approach, there are sometimes like some part of the field where the P levels are below that level, and some part of the field those are high. So there is a really a variability in soil P value. And then when we are deciding that how much our soil test P level is, it is already down, right? So it may limit some of the yield. So we need to get that up again. So that's one of the things that we are seeing, that with the deficiency correction approach, if we need to, if we need to improve that there. And then crop removal approach is just like very straightforward. You can apply what you get from the crop. Whatever your crop is taking up, and the phosphorus, you can replace that in that soil with that phosphorus. And then maintenance and build approach is kind of approach where it is intended to minimize the potential for nutrient limitation, that you are, putting nitrogen, I have been working a lot on nitrogen, so that's why I will keep on doing keep on saying nitrogen today. So you are kind of, maintaining the phosphorus above that critical level, so that you want to minimize any yield potential. So it again, in that cases, but some years that some dry years, when there is not good crop yield response, you may not see the value of what you're applying, what fertilizer you're applying to the soil. So in Nebraska, we are using deficiency correction approach, where again, we use a critical, soil test P levels to determine when we need to apply phosphorus into the soil. So again, you have seen this in the previous um, a presentation as well, a typical crop yield response to phosphorus. So where you can see that there is higher yield response at the lower soil test P value. And then what we call this is the response zone, where the soil P level is low. So when you apply more phosphorus, you will see the crop yield response, right? And then there is a critical level that we can decide above which there will be really no economic returns. So that's why we recommend applying nitrogen in this critical zone. But above the critical zone, what we call adequate zones, so that applying some phosphorus, sometime, again, it depends on the year, on the weather. So it may not, it typically would not give a, response, crop yield response to that at that level. So applying any phosphorus at this level would not, result in a yield increase. And then the next zone, I would say, is the drawdown range, where the phosphorus is really at excessive level. So any phosphorus that you are going to apply at that level would not result in any crop yield response. So at UNL, our recommendations about any nutrients, we are communicating through our extension circular, in addition to other communication ways. So we have extension circular for different nutrients, for different recommendations. One of the main one is the nutrient management for agronomic crops, where we have the recommendations for all different crops from eastern Nebraska to western Nebraska with different crops. And then we have nutrient management suggestions for corn as well in EC 117. So it was updated last year. So it is our most recent recommendations for corn for all nutrients, but not for nitrogen, because we recently updated our nitrogen recommendations in Nebraska for irrigated corn. So we just publish another NEP guide or extension circular for that. So in these publications, we have our UNL P recommendations as well. So for the P recommendations, we have two options. So the first option is where we are recommending a critical soil test P level of 20 parts per million for corn and 15 parts per million for corn and soybean. So if these are the equations that you can use to add any phosphorus fertilizer of what you are removing based on those soil critical levels. If you are below 20 parts per million, again, you can use this equation to see how much your crop has removed that you can add, right, for the grain here, and then you can add for the stover here as well. And same for the soybean. If you had a soybean, so you can add, if your P level is below 20 parts per million, you can add what you have removed from your crop. So if you are applying, after corn and soybean, you can combine those together. So this phosphorus recommendations were updated just before I joined GNL. So where we tried to be more on the conservation side as well, where our critical levels were 15 for continuous corn before, but we changed that to 20 parts per million. And then we are also even recommending that if your Bray1 is Bray1 p value for corn is between 20 to 25 parts per million, we recommend applying half of that after you calculate this one, the P values from there. But for corn on soybean, if your value is between 15 to 20 parts per million, you can again apply 50% of these, so that we just want, we are just trying to, minimize any, yield limitations in those conditions when the values are around 20 to 25 parts per million. Our second option is when you really got a lower yield, right? So either you have got less than 150 bushels per acre, or your Brave P1 value is really low, it's less than 7 parts per million, so that then we are recommending that you use these equations with 25 parts per million for corn and 17 for corn and soybean, because these would likely give you higher P recommendations than our option 1 that I shared earlier. But we still recommend that even if you are using this option 1, we have laid this out in this graph, that you can apply a maximum of 80 pounds per acre, not more than that, because there would be likely no crop yield response if you are applying all phosphorus at once. Okay, so in this our extension circular, we also have an Excel sheet based tool for the phosphorus recommendations that can be downloaded, and then you can just put your inputs for soil test P levels or P removal, and then that would calculate the P fertilizer for your crop. So the recommendations that we have again were based on several trials. Those were conducted for last couple of decades in Nebraska. So one of the trial that was conducted, it was in early 2002 to 2005. This was a Nebraska soil fertility project across the state. And then Dr. Charles Wortman and Richard Ferguson, Gary Hergert, Charles Shapiro, and others, they led on that project. So here is just a summary of that project for across different sites. So what we found, that when the P levels were below 10 parts per million, applying phosphorus resulted in increased crop yield, corn yield. There was a difference of 14 bushels per acre. And then when the P levels were below 20 parts per million, we still saw that there was some, again, crop yield response. So adding phosphorus in those fields resulted in higher crop yield response with a difference of 11 bushels per acre. But when the values were more than 25 parts per million, we did not see a significant crop yield response. There was a difference of, again, just 1 bushels per acre. So so that's how our recommendations were based, that if you're applying nitrogen over 25 parts per million base value, that you are not going to get a crop yield response. So again, there have been different studies. One of the study that was led by Richard Ferguson was recently published. It was in the central Nebraska. So where it was a long-term study for 20 years. And then, in this study, we calculated the critical level, and we found that it was 22.2 parts per million. This was kind of where our recommendation is. Though our critical level is 20 parts per million, but we are again between 20 to 25 parts per million. We are still recommending to apply some phosphorus so that we don't see any yield limitations. But again, there are always questions, right? So how if you are adding more P, right? We get these questions from industry, from our different stakeholders. Then, like, because there are, some co-ops, they are recommending higher phosphorus for some farms. So that the question that we have been getting, if we apply more phosphorus above your critical level, how about that? Have you done any study on that? But so this is just like a correlation between the crop yield and the Braven parts per million, soil value. This is again from the same project. So this each dot indicates a site. So these are different sites. These are not, points or treatments within each trial. So this kind of, line indicates that as you're applying more phosphorus, you're decreasing yield. That may not be true because, there are some other factors, those were not controlled in the study, so that, we may not, necessarily conclude that this could be because of the higher P application. But this definitely suggests that, when we are adding more P, it does not increase crop yield if our other, conditions are all right. There was another study that was conducted in the western Nebraska. Um, we don't have much corn on the western Nebraska. Most of the corn is either on the eastern side or the central part of the state. But this was one study on the western side where they again try to see the crop yield response with the different levels of Bre1P. As you can see that, below 20 parts per million, there was a good crop yield response. So with the P application, there was an increase in grain yield. But as you would apply more phosphorus, as you can see in this, graph, there was no crop yield response, again indicating, that higher soil test or higher P levels does not increase crop yield. We have also been doing some, starter fertilizer on-farm research where farmers, they showed interest in testing out the starter fertilizer. So here is a graph showing the yield difference between P and no P treatments on the y-axis. So you can see that with the lower soil test P values, there was higher yield differences. Like there was higher crop yield response when there were lower soil test P levels. But as the soil test P level increased, there was not a great crop yield response. Though we can see a scatter there. There was some crop yield response, but generally, above 25 parts per million, we were not seeing much crop yield response in this case in these studies. Okay, but again, we are always trying to address those questions that we are getting from the farmers. So is the UNL critical level of 15 or 20 parts per million appropriate for the crop yield? Especially again with the higher crop yields that we are now getting, is that really appropriate? And then again, what if we increase soil test P levels, to maybe 30 to 40 parts per million? How is that going to play a role? And then this is again based on the deficiency correction approach. What if like crop removal approach? We were so that's why we looked to compare our approach with the crop removal approach to see that how that strategy looks like compared to what we had at Nebraska. And then even what if we increase soil test P levels above crop removal approach? How is that going to play? So another interesting question that we were looking to answer, how does this annual weather pattern, really influence our phosphorus recommendations? So overall, what is the more sustainable approach, for improving the crop production in the long term? So there were, different studies. Those were conducted in different parts of the state. But what I would be sharing today is are the results from a long-term study that my predecessor Charles Shapiro led. He started this study in 2000. So it was 16-year long-term study where we have different treatments, as you can see here in this table. So we have no P, no fertilizer applied, and then we have fertilizer nitrogen applied but no P. These both were used as a checks. And then we have one treatment where we used crop removal approach to apply phosphorus. And then Bre15, this was again our recommendations, our critical level when the study started. So Bre30 and then Bre45. So when we started this study, the soil test P level at those time were 16 parts per million in all of those plots. So nitrogen was applied in all of those plots except no P, no N. So I want to start with weather effect on the phosphorus. Even before that, actually, I'm looking at all years. So here you can see again the soil crop yield response so to soil test value across all years, all 16 years. So what we found, this is a very typical crop yield response that you have been seeing in the previous presentations as well. So here what we found, our typical crop yield response, soil test P level was 23.8 parts per million, with a confidence interval range of 20 to 27 parts per million. So 23.8 was kind of above our critical value that we have, but again this was between like 20 to 25 parts per million, the recommendation that we already have to apply some phosphorus to avoid any yield limitation. And then, so again, whenever we are, recommending phosphorus across all the states, our recommendations are based on all the years, the data that we collect from across all different years. But we were also, since we had a long-term data, we were also interested to see how does this weather play, a role in our recommendations. Are our recommendations the same for all weather scenarios? What we did, we divided the data into different, moisture scenarios. So for example, here you can see the dry years and the crop yield response during the dry years. And so during the dry years, as you would expect, there was not much crop yield response, though we can see there was better fit. We can see some crop yield response, but the critical P levels were down. So those were 20 parts per million during the dry years, indicating that during dry years, you may not need to apply as much phosphorus as during other years. But looking at the normal years, we found the same critical levels as across all years. So it was like 23.9, almost close to critical level during all years, kind of indicating that for normal years, maybe our recommendations between 20 to 25 parts million, they are right on the spot. But when we looked at the wet years, we found a different critical levels. So for the wet years, our critical level was 27.1 parts per million. So that kind of indicate that, maybe those recommendations that we are recommending for our, across all years, they may not apply to wet years. During the wet years, maybe, again, crop is, taking up more phosphorus and yielding high, and more phosphorus is needed during those years. So definitely those years we need to apply more phosphorus, right? To increase our potential for crop yield in those specific years. And especially like if we are getting more and more wet years, we need to probably think that how do we want to change our P recommendations? Do we want to stay with our recommendations for the normal years, or do we want to see our recommendations based on the wet years? All right, so now I will switch gears from critical levels to more kind of the treatment effect on the crop yields. So here you can see that here I am, this graph shows the crop yield from average across all years. So you can see that here across all years there was a crop yield response. So first, on the more left, you can see no P, no phosphorus, and then you would see no P but with nitrogen, and then you will see CRP, and then Bray 15, Bray 30, and Bray 45. So you can see that there was, between the third and fourth treatment, the critical crop removal CRP had significantly higher crop yield than Bray 15 level. That was our recommendations earlier. But interestingly, what we found that CRP had similar effect as to higher P levels like Bray 30 and Bray 45. So Bray 45, you can see kind of a trend with higher yield with the higher P, but statistically we found the same effect, same crop yield between CRP and Bray 30 or Bray 45. So again, this is a kind of averaged across all the years, but the story was little different when we divided those into different weather years. So you can see more on the left for the dry years, we saw that the crop yield response to nitrogen. As you can see that the first treatment had lower crop yield compared to the rest of the treatments. And then though we saw relatively higher crop yield with the phosphorus application, but it was not significantly different than the treatment receiving no P application, but with some nitrogen application. So again, kind of indicating that during the dry years, you may not see a great crop yield response to phosphorus application as you would see in normal years. During normal years, you can see here, we saw a significant crop yield response to P application. So all our treatment receiving the P applications from CRP to BRAE 45 had higher crop yield than the treatment receiving no phosphorus. And then again, we saw kind of pattern that with higher P there was higher crop yield, but statistically we did not see any significant difference between those P treatments. But the story again was different for the wet years, where we again saw the P crop yield response to P. Here in this case, CRP was performing better than our BRAVE 15 P levels, and then it had similar crop yield response to BRAVE 30 and BRAVE 45. So again, kind of indicating that we may have different crop yield response to P during different weather years. Okay, so we also looked at the grain P concentration throughout our study period. But we did not see a significant effect, or with the different weather scenarios. So we found similar kind of trend across all weather scenarios where P application increased grain P concentration as we would expect. So generally, what we found across all of those scenarios, there was not much difference in grain P concentration between CRP and BRAE 15, but there were higher grain P concentration with the BRAE 30 and BRAE 45. So normally, even during dry years, you would say that there were higher P concentration compared to the other scenarios, indicating that P concentration is not an indicator for the crop yield. So it's sometimes there is a dilution or concentration of P with a lower yield. So it's not a good indicator, for having for the crop yield. But then we also looked at the corn grain P removal. So again, across different weather scenarios, we kind of saw the same trend. With higher P, we saw the higher P removal. Normally it is known that P removal is a typical good indicator of crop yield. We typically found a good correlation between P removal and the crop yield. But when you look at between those or among those weather scenarios, it may reflect those. It may not reflect that we did not see. But generally, across different treatments, we found that with higher P application, there was higher crop removal. But again, it was interesting to see during the dry years, though we are seeing higher grain P removal with a higher P application, but that was not the case for the crop yield. But for the normal years and wet years, we found that applying higher P led to more crop removal, kind of indicating that luxury P consumption at higher rate, regardless of the yield. So here is a graph that we looked at the phosphorus recovery efficiency. So phosphorus recovery efficiency, again, it's how much phosphorus we have recovered for those treatments for what we are applying, right? So what we found interestingly, that our BRAE 15, that's our recommendations, were recovering more phosphorus than the other treatments compared to CRP. And then when you're applying higher phosphorus with BRAE 30 or BRAE 45, definitely you are leaving more phosphorus, recovering less phosphorus with your crop. And then here is another graph kind of indicating the net P balance, how much phosphorus was left at the end of the season. And then how did it correlate with the change in BRAE P level from the start of the study. So what we generally found that there were, like when we did not apply any phosphorus, there were negative balance, right? So crop took up that phosphorus. And then with our BRAE 15, we found that some of those values were near to negative or slightly positive, again indicating that most of the phosphorus was recovered with our current recommendations. But with CRP, and then BRAE 30 and BRAE 45, there were higher net balance, indicating more. There was more P left at the end of the growing season. So we also looked at the economic impact of the phosphorus application strategies, because this is a question that we always get from the farmers. How does that return, right? What's the economic return? So here I'm showing the change in crop yield from those P treatments to treatments where we did not apply any phosphorus. So you can see that again CRP was doing much better than the BRAE 15, and it was kind of similar to BRAE 30, and BRAE 45. So among all of these, you can see that we found that higher crop yield with BRAE 45 and CRP. And then we calculated the net income just based on the price of the corn. So you would definitely see that higher price, higher net income with the CRP compared to BRAE 15, or if there was higher return with the BRAE 45. And then, this is the application cost. As you are applying more phosphorus, you would, expect more cost, as you can see with the BRAE 35, BRAE 30 and BRAE 45. And then we calculate, this is P applied, this is the cost. And then we calculated the net return based on the cost of the fertilizer and the cost of the corn. So what we found that though we did not find a significant difference between all of those due to high variability, but we definitely found that there was higher net return for the CRP than the BRAE 15 and BRAE 30, and then BRAE 45 also had higher, comparatively higher net return than BRAE 15 and BRAE 30. So, there are two scenarios. Either you look at absolute return as you are seeing here, or the ROI, how much you have invested, what is your ROI. So, since most of the phosphorus was consumed from BRAE 15, we are and even the CRP. So we found that there was higher ROI from the CRP and BRAE 15 compared to BRAE 30 and BRAE 45. Then we also, tried to see that economic impact across different weather years, and we found a different story here as well. During the dry years, there was a negative return, as we would expect, right? During a normal years, so you can see that during normal year, we found that there was higher crop yield, the difference in crop yield with the highest level of phosphorus with BRAE 45 compared to all of the rest of the treatments. And then for the net return, we found that there were higher return with the BRAE 45 compared to the rest of the treatments. The ROI, it was higher with CRP and BRAE 15. Looking at the wet years, so a change in yield, it was, though we did not see any significant effect, but we found that there was relatively higher, yield difference for the CRP and the BRAE 45 compared to the other treatments. Same for the net return, we found relatively higher value with the CRP and BRAE 45, though ROI was higher with CRP and BRAE 15. So just to conclude, as I am approaching my time, I think that, based on the data, that we have seen that, we may need to think, do we need to change our P recommendations based on the weather scenario? Because we don't want to limit our yield, during any years. If we are getting more wet years, do we need to base our recommendations based on the wet year? Because as you have seen that in wet years, we found higher crop yield with the BRAE 45. So, that indicates that potential yield loss if we are, just staying with BRAE 15 or BRAE 25 in wet years. So there will be a potential yield loss. So again, among all of those studies that we have found that generally, CRP was a better strategy compared to our BRAE 15 strategy that we have been using. But again, during wet year, we found higher BRAE 45. So that was really giving higher return. So, higher P level, higher P levels could be used in those fields probably where there are, less chances for P losses, right? Or they are not due to any budget constraints, and the yield expectations are high, or all other growing conditions are good. So overall, this was some data from one of our long-term sites. So we are still exploring data from other sites as well, and probably we will have to see if we need to further revise our P recommendations based on the strategies or based on the weather years. So with this, I would like to appreciate all the faculty those have been involved in the P work, especially Dr. Charles Shapiro and my previous postdoc Sweta Patel, who has moved to Minneapolis. Really appreciate his work on this, and with this, I would be happy to take any question. Okay, questions are here. All right, so what in the drawdown range of Nebraska's P recommendation? What rate of P test level decline can you expect on Nebraska soils? So what we have seen previously, we have seen that P test level, they decline, like if I'm getting these questions right, so P test level, they normally, decline about, 25 parts per million. They start to decline and they would affect the crop shield. But typically we again, it depends on the soil type. If there is a, sandy soil, those decline quickly compared to the silt clay loam soil. I don't know if I answered this question right or not. I'm just trying to go through all of these. So some agronomists have suggested to optimize crop phosphorus using zinc. Soil test levels should be around 10% of phosphorus soil test levels. Have you looked at those studies? We have actually not looked at those studies. So phosphorus, yeah, we have not looked at the other nutrients or interaction of those with the phosphorus in Nebraska, at least. For a forage production operation here, silage, has there been studies on P effects on forage quality? So that's the same kind of answer. So we have not been looking much on the phosphorus. Recently in Nebraska, there has been much focus on the nitrogen. So I am not aware of any studies those have looked at the forage quality. Right, that's a good question. So yeah, so we applied phosphorus, just so there was an equation that was used to calculate how much phosphorus was needed to increase soil test levels by 1 ppm. So based on that, whatever our basic soil test level was, so we just took that factor to increase the soil test P level using that equation. And then we have also published this study in agronomy journal. So if you want to look into detail how did we increase that soil test P level, you are welcome to look at those equations. Any other question?
Questions in the audience? Right on time, so thank you very much.
Sure.